talk about how to graph rational functions. Rational functions. Okay, what is a rational function? It's one polynomial divided by another polynomial. Both of these are polynomials. You divide two polynomials, what you get is called a rational function. Now, we need to define a couple of things. We need to define vertical asymptotes and horizontal asymptote. And x value, which makes their denominator equal to 0, and that means at the same time the numerator is not 0. Is called the vertical asymptote. The x value that makes q of x 0 but does not make p of x 0, that x value, you have a vertical asymptote at that x value. You have a vertical asymptote at an x value which makes the denominator equal to 0 and the numerator not equal to 0. You have a vertical asymptote at an x value which makes the numerator, which makes the denominator 0 but not the numerator. That is the definition of a vertical asymptote. A horizontal asymptote. If the degree of the numerator is greater than the degree of the denominator, hold on a second. We'll say plus 1. You take the degree of the bottom and you add 1. If the degree of the numerator is larger than that, then no horizontal asymptote. You have no horizontal asymptote. Horizontal asymptote. If the degree of p of x is less than the degree of q of x, then horizontal asymptote at y equals 0. Number 3. If the degree of p of x is identical to the degree of q of x, then horizontal asymptote at y equals a over b, where, so example of p of x is a sub n x to the n plus lower terms, etc., So the degree of P is n, and if the degree of Q, Bn, if Q of x is Bn x to the n plus lower terms, some number, Bn minus 1, to the x minus 1, etc. Then we will say that the horizontal asymptote is y equal an over bn. That is, when the highest powers are the same, just divide the two numbers of those highest in front of those highest powers. So the vertical asymptote is y is equal to a sub n divided by b sub n. And kind of ran out of room for number 4, so let me put it up here, please. If the degree of the top is just one more than the degree of the bottom, we talked about when the degree of P was less, when the degree of P was less than the degree of Q. We talked about when they were equal. Now what about when P is bigger than Q? Well, if P is bigger than Q by 1, we use this rule here. We use rule number 1. Rule number 4 is if the degree of P is equal to the degree of Q of x plus 1, then do long division to get horizontal asymptote. Example, if you have x squared over x plus 1. That would make my life a little bit easier. Okay. So suppose you have that. Well, yikes. So you're going to have an x, that gives you x squared plus x minus 1. X squared minus 1 plus 1 over x plus 1. That's what you would get if you did their long division. Now, when x is really, really large, this goes to 0. So the vertical asymptote would just be that piece. They would get close to the line y equal x minus 1. Okay, that's how you do number 4. You do the long division, and then the remainder part you ignore. And the horizontal asymptote, in this case, would be y equal x minus 1. Okay. Now, let's talk about how we're going to graph this after we get some information. First of all, the near vertical asymptotes, the y values are at the extremes. Either they're getting close to positive infinity or negative infinity. Here is your x and your y-axis. Let's suppose when x equals 2, that's the horizontal asymptote. That means when x gets very, very large, the graph will get close to that line. For example, it can be crazy when x is small. But when x starts getting large, it's going to get closer and closer to that line. Okay, that's what horizontal asymptote means. Get rid of this picture, and then we'll talk about vertical asymptotes. your graph had vertical asymptotes, say here, and say here, and say two others, what you need to do is find out what happens. So let's just label these A, B, C, and D. If x is a little bit less than A, that means to the left of A, you need to find out what the y value is. Either it's plus infinity or minus infinity. At a vertical asymptote, it will never be anything but that. If you're a little bit less than A, maybe it's positive infinity. So notice I put a dot up there. If you're a little bit more than A, maybe it's a negative infinity. At B, less than B, let's suppose it's more than infinity. More than B, let's suppose it's negative infinity. If you're a little bit less than C, suppose you're a negative infinity. If you're a little bit more than C, maybe you're also a negative infinity. Actually, in this case, I'd rather, if x is more than C, it should be a positive infinity. Oh, I guess it doesn't matter. If you're a little bit more than C, oh yeah, you're a positive infinity. If you're a little bit less than D, you're also a positive infinity. And if you're a little bit more than D, maybe you're also a positive infinity. Okay, and you have a horizontal asymptote like such. Now, we broke this graph into a few regions. Region 1 is to the left of A. Region 2 is in between A and B, which is down here as well. Region 1 is there. Region 3 is between B and C, 4 between C and D, and region 5 greater than D. Let's do the extreme ones. Let's do 1 and 5. Well, at 1, we know we're up at positive infinity, and we have to get close to that line. And the graph will go like this. Nice and smooth. If you're positive in region 5, sometimes it may turn out that the graph gets closer to that line, but it's below the line. Well, in this case, you have to get close to the vertical asymptote up here, and then you'll come down and get close to the horizontal asymptote. Now in the middle, let's do region 4. In the middle, it's somewhat easy. If the two dots are on top, you draw a U shape. Question is, you don't know how low to go. I admit that. That's what Calc 1 will be for. Between B and C, they're both at the bottom. So you draw your U shape like that. Upside down U shape. Between A and B, we go from the bottom to the top. That graph is just like this. It goes up like that, and it comes down like that. Okay, remember or note that if you started high and you had a finish low, then the graph would just be pretty much what we drew, but backwards, or whatever language you prefer to call it. But they're nothing but nice and smooth curves. Biggest question you should have at this point is, how do you find these infinities and negative infinities? Let's do a problem. Actually, let's look at one more like we just had. Suppose you have these vertical asymptotes. Say 3 of them. 1, 2, and 3. And suppose the degree of the numerator was just 1 larger. Here's the x-axis. 1 larger than the degree of the denominator. So that's the case where you do long division. And it's right here is the y-axis, and you did long division, and you go y is equal to x plus 2. That's this line right here. This is the line, y equals x plus 2. Okay, and you find, so that's your horizontal asymptote. But since it's not horizontal, we call it oblique. We call it oblique. Doesn't matter what we call it. When x gets large, the graph is going to get close to this line. Okay, so now let's suppose that we learned that when x is very large, so again, vertical asymptotes are at A, B, and C. Suppose when x is very to the left of A, a little less than A, we're at negative infinity. A little more than A, positive infinity. Less than B, positive infinity. More than B, positive infinity. Less than C, negative. And also more than D, negative. So we talked about our intervals. We have 1 to the left of A, between A and B, between B and C, and greater than C. Okay, let's do the extremes. Let's do 4. 4, remember, you have to get closer and closer to this dashed line. And you have to get closer to this curve. Excuse me, this line up here. So it goes something like that. Goes something like that. Okay, let's do region 1. Region 1 is going to go like that. It's getting closer to this line here. Getting closer to this line that's now in blue. And is getting closer to the oblique asymptote. Okay, now between A and B. Well, between A and B, they're both high. They're both up here and here. So that means it goes like that. Done. Between B and C, one's high and one's low. High and then low. Nice, smooth, simple S shape. And there's your graph. There it is. The hardest, biggest thing is to find these values. See what happens when x is a little more and a little bit less than a vertical asymptote. So why don't we look at a problem? Suppose you were asked to graph y is equal to x plus 4 over x squared minus 1. Well, to find the vertical asymptotes, you might want to factor the denominators. X plus 1, x minus 1. So the vertical asymptotes are at x equals negative 1 and x equals plus 1. Negative 1 makes this 0, plus 1 makes that 0. Neither of these numbers make the numerator 0. Negative 1 plus 4 is not 0. Positive 1 plus 4 is not 0. We have vertical asymptotes that are plus minus 1. Horizontal asymptote at y is equal to 0 because the degree of the bottom is 2 and the degree of the numerator is 1. Whenever the degree of the bottom is higher The horizontal asymptote is at 0. Okay. Now we need to do some bookkeeping. We need to see what happens when x is a little bit more than 1. How about x is a little less than 1? That means less than 1. X is a little bit more than 1. How about negative 1? Negative 1 a little bit less, and x is negative 1, but a little bit more. We want to find out what the y value is. Okay, so we need to find the y values when x is a little bit less than 1, a little bit more than 1, a little less than negative 1, and a little bit more than negative 1. And the nice thing is, we know that y is infinity. Okay, when x is anywhere near a vertical asymptote, the y value is infinity. The question is it positive infinity or negative infinity? That's what we want to know. Well, we have x plus 4 over x plus 1 times x minus 1. When x is anywhere near 1, that one's going to be near 0. Now, if x is anywhere near 1, 1 plus 4 is 5. It'll be near 5. It'll be positive. If x is near 1, the next factor will be positive. Same for the one underneath, for the same reason. Anywhere near 1. But when x is near 1, this one can be positive and negative. X minus 1 is greater than 0 when x is bigger than 1. Well, the second case is bigger than 1. The first case is not. If x is less than 1, if x is less than 1, and you go to that next last factor, if you're less than 1 and you take away 1, you'll be negative. That's why I put a negative there. The overall sign is negative. In this case, infinity. In the second one, it's positive infinity. That's what happens when x is near 1. Now, what if you're near a negative 1? Well, if you're near a negative 1, then this factor, this one, is going to have sign changes. But if you're near negative 1 plus 4, you're going to be near 3. It's going to be positive in both of the last two. The second factor in the bottom, if you're anywhere near negative 1 and you take away 1, you're going to be negative. Negative. But what happens to this factor, this one? Well, when is it positive? It's positive when x is bigger than negative 1. That means it's negative when x is not bigger than negative 1. That is when x is less than negative 1. If you want to actually work out when it's negative, go for it. X is less than negative 1. I'm going to put a positive, because that's when x plus 1 is positive, when x is greater than negative 1. That means negative 1 with the plus sign. So it's going to be positive in the bottom, and it's going to be negative in the top. Their overall sign here is positive. The overall sign here is negative, so it's negative infinity. And with this information, we can draw our graph. along with the fact the horizontal asymptote is at 0. With this information, we can draw our graph. Okay, let me erase this so I have space to graph. And in the corner, I want to write something. We had that when x went to 1 negative, y goes to negative infinity. X is a little bit more than 1. Y was positive infinity. When x approached negative 1 from the left and x approached negative 1 from the right, the values we got were infinity and negative infinity. And the horizontal asymptote is y equals 0. With this information, we can draw our graph. Horizontal asymptote at y equals 0. Okay, so let's graph this. X, y. Now it's hard to draw. The line y equals 0 is their x-axis. And it's hard to dot a line that's already drawn solid, but I'll try it. It's in green. Okay, the horizontal asymptote is y equals 0. Now the vertical asymptotes are at 1 and at negative 1. Okay, so we have 3 regions. We have to the left of negative 1, we have the middle region between negative 1 and 0, and we have greater than 1. Okay, when x is a little bit less than 1, y is negative infinity. That's right here. Excuse me a moment. That's right here. Okay. If you're a little bit more than 1, you're at positive infinity. If you're a little less than negative 1, that means to the left of negative 1, you're at positive infinity. That's what this says. Okay, that's what this one says, excuse me. If you're a little bit more than, that's what the plus sign means. If you're a little bit more than negative 1, you're at negative infinity. You're here. Okay, and you have to get close to the line y equals 0. So the leftmost region goes like that. The rightmost region goes like that. The middle region, it goes up and down. Usually, 99% of the time, it's going to hit the high right in the middle of negative 1 and 1. Or in the middle of those 2 vertical asymptotes. What's in the middle of negative 1 and 1? Smack dead in the center, 0. If you plug in 0, you'll see that you get negative 4. 0 plus 4 in the top is 4. 0 squared is 0 in the bottom. Take away 1, you get negative 1. That's negative 4. It crosses a negative 4. And the middle region goes something like that. When you take Calc 1 next semester, you can use calculus to find exactly where that max is. And it's going to be at 0. It's going to be when x is 0. And there's your graph. They're a bit tricky, but these can be done. Suppose you have x cubed divided by x squared minus 5x plus 6. Well, if you factor the bottom, since you have an understood 1x squared, you want to factor it as x followed by a number times x followed by another number. And the two numbers should multiply up to the constant, should multiply up to 6, and add up to the number in front of x. And two numbers that do that are -2 and -3. And the top is x cubed. So we have vertical asymptotes at x equals 2 and x equals 3, because 2 will make the bottom 0. 2 times whatever, 0 times whatever. In this case, 0 times -1. If x is 2, you have 0 times -1, and that's 0. If x is 3, 3 minus 2 would be 1, and 3 minus 3 would be 0. 1 times 0 is 0. These are numbers that are making the bottom 0, and they do not make the top 0. Because the only number that you can cube and get 0 is 0. And we never said that vertical asymptote is at 0, only at 2 and 3. Now for horizontal asymptote. Since the degree of the top is exactly 1 more than the degree of the bottom, we have to do long division. We have to do x squared minus 5x plus 6 into x cubed. And if you need, no x squared, no x's, plus no constant. Multiply by x. If you multiply what I just put brackets around by x, you'll get x cubed minus 5x squared plus 6x. And then you subtract. And you'll get 5x squared minus 6x plus 0. And then you multiply by 5. Of course, you'll get 5x squared then. If you multiply 5 by x squared, you'll get 5x squared. If I multiply all of that by 5, you get 5x squared minus 25x plus 30. And then if you were to subtract, you get 19x minus 30, which is the remainder. Because the degree of this is finally, which is 1, is finally less than the degree of that. So here is your vertical asymptote, your horizontal asymptote. That is your oblique asymptote. Because the remainder, like I said earlier, the remainder you ignore. Because when x is really, really large, and take large x values, and you'll see when you plug it in for x, this gets closer to 0. Okay, so the horizontal asymptote is just y equals x plus 5. Y equals x plus 5. You have to do the long division to see that. Before I forget, y equals x plus 5. You have a horizontal asymptote, that is oblique asymptote at y equals x plus 5. It's not a horizontal, it's an oblique. The only time it's not horizontal is when the degree of the numerator is 1 more than the degree of the denominator. Okay, now 2 and 3. What happens when x is a little bit more than 2? A little bit less than 2? What happens to y, excuse me? What happens to y when x is a little more than 3? What happens to y when x is a little less than 3? The nice thing about this is there aren't too many answers. These are plus or minus infinity. Okay. What is y equal? Is it plus or minus infinity? Y is it plus or minus infinity? And that line that I'm drawing is a division line. Because y happens to be a fraction. Okay, now let's look at x cubed. If x is anywhere near 2, When you cube it, it'll be positive. And x is anywhere near 2, even a little bit less than 2. If you cube it, it'll be positive. If x is anywhere near 3, if you cube it, it'll be positive. Anywhere near 3, even a little less than 3, you cube it, it's positive. Now, what about x minus 2? When is it positive? Well, if you add 2 to both sides, you see it. If x is more than 2, I'm going to write positive for the bottom left factor. Well, this clearly says x is more than 2. That's positive. This clearly says it isn't. It says it's less than 2, minus. If you're little more than 3, well then of course you're more than 2. If you're just a little bit less than 3, of course you're more than 2. Okay, now let's go to the bottom right factor. When is it bigger than 0? That's when x is bigger than 3. If you're anywhere near 2, you're not bigger than 3. That means you're negative. If it outright says x is more than 3, well then of course you're positive. If you're less than 3, you're negative. And divide those signs, it'll be negative infinity. Here, do the division, becomes plus infinity. Plus infinity, divide those 3, you get negative infinity. And there's your graph. Let me write down this information a little bit smaller on the top corner so I'll have room to graph. If you're more than 2, it's negative infinity. If you're less than 2, it's positive infinity. If you're more than 3, it's positive infinity. Less than 3, negative infinity. And y equals x plus 5, that's the horizontal asymptote. And I'm sure I erased this, and then I put the h back. It's not horizontal this time, it's oblique. Whenever the degree of the top is 1 more than the degree of the bottom, we call it oblique. If the degree of the top is more than 1 more, 2 more, 3 more, the degree of the top is 17 more than the bottom, then we say that there is no horizontal asymptote. And by design, if the degree of the numerator is 1 more than the degree of the denominator, when you divide and ignore the remainder, you're going to be left with a linear first degree, a line. Okay, let us draw this. Here is the line, y equals x plus 5. Let's start off with that. And we have vertical asymptotes at 2 and 3. 1, 2, 3. I'm even going to erase the top. Okay, so 1 by 1. If you're a little bit more than 2, you're at negative infinity. That's right down there. If you're a little bit less than 2, this says less than, that says a little more than. If you're a little bit less than 2, that means to the left of 2, you're at positive infinity, way up here. Which leads me to think I should raise the y-axis. Okay, now on to 3. If you're a little bit more than 3, you're at positive infinity. a little less than 3, you're at negative infinity. Okay, so for the end parts, the right end is going to go something like that. The left end point is going to go something like this. The middle one, between 2 and 3, think the graph was x cubed over x minus 2 times x minus 3. Well, what happens when you plug in 2.5? Well, you're going to get 5 over 2 cubed in top. Now, 2.5 minus 2 is a half, and 2.5 minus 3 is negative a half. So on the top, you get 125 over 8, and on the bottom, you get negative a quarter, and this becomes a negative 125 over 2. That is 62.5 negative. Okay, so it's your scale. I would draw it first, and then I would say that value is negative 62.5. And there's your graph. Get closer and closer to the oblique asymptote as well. For example, to draw that one a little bit bigger and clearer, let's make 2 assumptions. Just for visual purposes, let's suppose the line really went like this, a little bit lower. Let's just suppose that. And when x is more than 3, we are at positive infinity. So you have to get closer and closer to the vertical line, and you also have to get closer and closer to the oblique line. And it looks more like that. I mean, of course, it can come down lower, things like that. Those minor details we'll pick up in calculus. The graph could look like this. Could look like that. Can look like this as well. Just get closer and closer to both of them. Don't go crazy in there. Nice, smooth U shapes. Nice, smooth curves. So, for completeness, here is your graph. Well, actually, the line was really up here. So there it is. Where this is not there. Let's try one more. Suppose you have y is equal to x to the 5th plus 1 divided by x plus 3 times x minus 2. You have vertical asymptotes possibly when the denominator is 0, like negative 3 and possibly 2. And I'm going to keep those 2 because neither one of them make the numerator 0. Okay. Horizontal asymptote, there is none because the degree of the numerator, remember the bottom is going to be x squared plus stuff. The highest power of x is going to come from multiplying the highest power of x's. X to the 1 times x to the 1 is x squared. The degree of the top is more than 1 more than the degree of the bottom. That means there's no horizontal asymptote. You have to remember that little table I gave you. Okay, now we look at the asymptotes. A little bit more than -3, a little less than -3. A little bit more than 2, a little less than 2. Well, we know that it's going to be infinity. Is it plus or minus? Is it plus or minus? Well, let's see. The top, x to the 5th plus 1. If you take any number near -3 and multiply it by itself 5 times, you're going to get a fairly large negative number. And then when you add 1, it's going to stay negative. Okay, let's go to the bottom one, x plus 3. That one's going to change at 0. Think about it. If you here's 3. If you add 3, here's -3. If you add 3, you get to the 0. If you start to the left of -3 and you add 3, you'll be negative. If you start more than -3 and you add 3, you'll be to the right of 0. Okay. X plus 3 is going to be 0 if x is bigger than -3. Well, in the first case, x is bigger than -3. In the second case, it is not. What about, oh, excuse me. So, this result should go in the bottom. So what happened? These two are negative on the top. And the bottom one, if you're more than -3, x plus 3 is positive. More than -3, this is less than -3. It says less than -3. Now what about the last factor? X minus 2. X minus 2. Well, this is positive when x is bigger than 2. But if you're anywhere near 3, near -3, you're not bigger than 2. That means you're going to be negative. The overall sign is positive on top and negative on the bottom. When x is near -3 but a little bit more, then y is going to be near positive infinity. If x is near -3 but a little bit less, then y is going to be close to negative infinity. Okay, let's do this all over again for the other asymptote. Last time we did it all at once, this time I did it in 2 steps. So let me do the bookkeeping up here. -3, a little bit more, we get plus infinity. A little bit less, got negative infinity. 2 more, 2 less. A little bit more than 2, then y is going to be, and a little bit less than 2, what is y going to be? Well, if you're anywhere near 2 and you get raised to the 5th power, you're going to be positive. You'll be near 32. You add 1, it's going to be positive. In both cases, it's going to be positive. What about x plus 3? If you're anywhere near 2, if x is anywhere near 2, a little bit less, a little bit more, then you add 3, it's going to be near 5. They're going to be positive. What about that last factor? X minus 2. What's going on with x minus 2? Well, that one's going to depend on if you're a little bit more than 2 or a little bit less than 2. if x is more than 2, then x minus 2 will be positive. And I want to know about x minus 2. If x is more than 2, it'll be positive. Otherwise, that is, if it's less than 2, it'll be negative. This overall sign is positive. This overall sign is negative. The numerator is positive. A positive times a negative is a negative. Positive over negative is negative. Okay, more than 2, we're at infinity. Less than 2, we're at negative infinity. And we have no horizontal asymptote. That is, when x is very large, the graph goes to positive infinity or negative infinity. And when I say large, I mean positive large as well as negatively large. Okay, now graphing, hopefully it's not a big deal. Vertical asymptotes at 2 and at negative 3. Here's one of them. Here's the other one. When you're a little bit more, that is to the right of negative 3, you're at positive infinity. A little bit less because of the negative, you're at negative infinity. A little bit more than 2, positive infinity. A little less than 2, negative infinity. I guess what we need to talk about is, since there's no vertical asymptote, we have to talk about when x goes to positive infinity and x goes to negative infinity. We know the y value is infinity again. We know the y value is infinity, positive and negative. If you take a really, 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 really large positive number and raise it to the fifth, it'll be positive. You add 1, it's going to be positive. Take a really, really large number and you add 3, it'll be positive. Really, really large positive number, take away 2 is positive. We're doing net positive divided by positive times positive. When x is really large, the top is positive, and the 2 factors in the bottom are positive, it's positive. Now what happens if x is very, very negative? Negative 100 billion, a very large negative number. Well, you raise a very, very large negative number to the 5th power, it'll be negative. Negative very much, negative 39,212,000. Be very negative. Well, adding 1, it's still going to be negative. You have now in the bottom, you have a very, very large negative number, and you add 3 to it, it'll stay negative. If you take away 2, it'll get more negative. We now have a negative divided by a negative times a negative. Well, that's a negative. That's a negative result. That result is negative. So when x is negative, y goes to negative infinity. So when x is positive, when x goes to negative infinity, the y value is negative. When x goes to positive infinity, the y value is positive. The y value is positive. Okay, the middle term goes something like that. The end term, it has to get closer and closer, and then it takes off again. Of course, it could have come down a lot lower, and then go up. Again, in Calc 1, you'll find out exactly where that point is. For example, if I told you the lowest point was going to be there, well then you would draw something like that. And next semester, you'll learn how to find the lowest value. But for right now, this is the best we can do. To the left, same scenario. We have to get closer and closer to the vertical asymptote at -3, but we also have to go to negative infinity. So the graph goes something like that. There is a graph. Okay, it's a very hard section. Just have to do a lot of problems. You can do it though.